An inverted cone is 20 centimeters tall, has an opening radius of 8 centimeters, and was initially full of water. The water drains from the cone at the constant rate of 15 centimeters each second. The water surface level falls as a result. At what rate is the water level falling when the water is halfway down the cone? So let's start by drawing a diagram. So this is the inverted cone. It says it's 20 centimeters tall, and it says the radius is 8. So the question gives us the rate that the volume is decreasing. So that would be dV over dt equals negative 15 centimeters per second, because that's the rate the water is leaking out of the cone. And it's asking what rate the height of the water is falling when we're halfway down the cone. So when we're halfway down the cone, that's going to be h equals 10 centimeters. So the question's asking for dH over dt because it's asking the rate the water level is falling. So that's what we're looking for. So recall the formula of a cone, which is V equals pi r squared h over 3. And you can see it's dependent on the radius and height. So if we're going to want to solve this, we're going to have to sub in one or the other. And since we're looking for dH over dt, we're going to sub in the expression for r to get rid of it. So the ratio of radius and height is r over h equals 8 over 20. And if we rearrange that and simplify, we'll get 2 over 5 times h equals r. So if we sub that in, we're going to get 2 over 5 squared h squared times h over 3. So if you plug that in, you're going to get 4 over 75 pi times h cubed. So now that we have it all in terms of h, we could differentiate with respect to time. And we'll get dv over dt equals 4 over 75 pi times 3h squared dh over dt. So we have the height at that moment, which is 10 centimeters, and we also have dv over dt, which the question gave us. So now if you just rearrange for dh over dt, you'll get dv over dt all divided by 4 pi over 75 times 3h squared. So now let's plug it in. Negative 15, 4 pi over 75 times 3 times 10 squared. And if you plug that all in, you'll get negative 0.298. And looking at this expression, we could see the units will be centimeters per second. Gravel is being dumped from a conveyor belt at a rate of 50 cubic feet per minute. It forms a pile in the shape of a right circular cone, whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 17 feet high? So this is the conveyor with the gravel, and this is the pile that it's forming. So h will be the height, and d will be the diameter. From the question, it says the diameter and height are always equal, so we could just make a note of that over here. And it says gravel is being dumped from the conveyor belt at a rate of 50 cubic feet per minute. So that's the rate that the volume of the cone is increasing. So dV over dt of the cone is 50 feet cubed per minute. The question's asking how fast the height of the pile is increasing, so that's dH over dt when the pile is 17 feet high. So dH over dt when h equals 17. And since h equals d, that's also equal to d. So the volume of a cone is equal to pi r squared h over 3. And since we're in terms of diameter, we could replace the r with 2 times r equal d. So radius is diameter divided by 2. So let's sub that in and simplify. So let's just write that clearly. So now we have to sub in the expression d equals h because there's two variables here. So since the final answer is looking for dh over dt, we should get rid of the d. So let's sub that in. So d squared will be h squared times h is h cubed. So volume equals pi over 12 h cubed. Now we could differentiate with respect to time. We're going to get 3 pi over 12 h squared dh over dt. So we have dv over dt, which is the 50 it gave us. We also have the height. And we're looking for dh over dt. So let's just rearrange for that. So 50 over 3 pi over 12 times 17 squared. So if you plug that all in, you'll get 0.22. And the units would be height over time. So in this case, it's feet over minute. And that's the final answer. Suppose that we pump water into an inverted right cylindrical conical tank at the rate of 5 cubic feet per minute. The tank has a height of 6 feet and the radius at the top is 3 feet. What is the rate at which the height of the water level is rising when the water is 2 feet deep? So let's start by drawing a diagram. The question says it's a height of 6 feet and a radius at the top of 3 feet, so let's draw that. So the question gives us the rate that water is being pumped into the tank. So in other words, how fast the volume of water in the tank is increasing. So that would be dV over dt equals 5 cubic feet per minute. And it's asking when it's 2 feet deep. So h equals 2 feet. So we're going to need the ratio between the height and radius, which is 6 over 3. So the height is always going to be twice as big as the radius. We'll need that for later. So again, we're going to use the volume of a cone. And the question's asking the rate at which the height of the water level is rising. So since we have two different variables, we're going to want to keep the h and get rid of the r. So let's rearrange this for r, and we can sub that in. And let's simplify. H squared over 4 times h over 3. So that's pi h cubed over 12. So let's write that over here. Now we're looking for dh over dt, so we're going to differentiate with respect to time on both sides. So 3 pi h squared over 12 times dh over dt. And we could rearrange for dh over dt. And we'll get dv over dt, which the question gave us was 5, over 3 pi. The h is when it's 2 feet squared over 12. So plugging that all in, we're left with 1.59. And the units in this case are feet per minute. So feet per minute. And that's your final answer. Thanks for watching.